Let us begin a new chapter today. That is composition of matter. What is meant by matter? Matter means substances. There are number of substances in the world. We can say that on the earth, in the water, even in the air. Now, what is meant by composition? Composition means with which things a substance is made or a matter is made. Now here we can say that there are number of substances and each and everything is made with the help of different particles. So we can say that a substance is made with which particles all together. We can say that that is the composition of that particular substance. For example, water. If you are taking water, water is made with the help of oxygen as well as hydrogen. So we can say that composition of water means with what water is made, with the help of oxygen as well as hydrogen. Similarly, if we consider air, air consists of nitrogen, oxygen, water vapor, then inert gases. Inert gases means helium, neon, argon, krypton and xenon. So these all gases are known as inert gases. Helium, neon, argon, krypton and xenon. So we can say that air contains different types of gaseous matter, like that nitrogen, oxygen, water vapor, inert gases. Inert gases itself is of 5 types. So we can say that now composition of air is this thing. That means air is made with the help of which all things. Water is made with the help of which all things. Now carbon dioxide. If we say carbon dioxide, this contains carbon as well as oxygen. So we can say that with what a particular substance is made. That is known as a composition of a matter. Now we are going to study about what are the different states of matter. A substance has how many states, or which all states a substance is available. We can say that different states of matter are solid, liquid and gaseous state. Solid state, liquid state and gaseous state. So there are 3 different states of matter. They are solid, liquid as well as gaseous matter. Next one, what is the difference between ice, water as well as water vapor? So what is the difference between ice and water? Ice is available in solid form. Then water is available in liquid form. And here steam means a water vapor, that is available in the form of gaseous. So we can say that here the difference in ice, water as well as steam is ice is in solid state, then water is in liquid state and steam is in gaseous state. Now we will see the other question, that is what are the smallest particle, or which are the smallest particles of a matter. Now we can say that a particular substance is made with the help of very tiny particles. These tiny particles are known as atoms. So we can say that smallest particles of the matter known as atoms. So which are the smallest particles of the matter? Smallest particles of the matter are known as atoms. They are very tiny particles. They are indivisible, even they are invisible. We cannot be able to see them, even we cannot be able to cut them. Such a tiny particles. They are known as atoms. Next one, what is there? What are the different types of matter? Now matter itself is available in different forms. They are element, then compound, then mixture. What are the different types of matter? Matter is available in different forms. They are element, compound and mixture. Now, what is meant by intermolecular attraction? Now here, solid form, liquid form as well as gaseous form substances are available. Now these all substances are made with the help of molecules. Now among them or in between them, how much attractive force is there? That is known as intermolecular force of attraction. Let us see with the help of diagram. Here solid, here liquid, then here gaseous state substance. They are in different state now. Solid state, liquid state as well as gaseous state substances are there. One particular substance itself we can count now. That is either we can take as ice. Ice is in solid form. Liquid, that is water. Then gaseous form, that is water vapor or steam. Now ice, solid form, liquid or water, that is in the liquid form. Then here all these places are particles. I will draw and show you how that intermolecular difference I will show you. Here now intermolecular force of attraction among the particles which are present in the solid state, which are present in the liquid state, which are present in the gaseous state. In them, how much attractive force is there between the molecules, that I am showing you. In case of solid particles or solid substances which are made with the molecules, they all are very close to each other. With tiny particles it is made. These all particles are very close to each other. As a result of it, among them so much or very much attractive force is there. So we can say that intermolecular force between the molecules which is present in the solid state is very high. More we can say intermolecular force of attraction between the molecules which are present in the solid state is very high, very much more, or we can say very more or high we can say. Intermolecular force of attraction between solid particles is very high. So much attractive force is there. Now when liquid particles will be there, water particles will be there, their particles are little far from each other. As a result of it, their attractive force is little less. Here each and every particles which are present in the liquid or in the water, they are little far from each other. They are also made with the help of molecules, even though these particles, in between these particles have little distance. As a result of it, their attractive force is little less. When we think of the particles with which a gas is made, they are very far from each other. As a result of it, among these particles, very least force of attraction is there. So here, solid substance is made with the help of molecules which are very close to each other. As a result of it, intermolecular force of attraction is very high. Once it changes to water, those particles are little far from each other. As a result of it, their intermolecular force of attraction is less. When we come to water vapor, those particles are very far from each other. As a result of it, among these molecules, attractive force is very less. Now, one more thing we will study. Solid substance, after supplying heat, transforms to liquid. Again, the liquid substance, after getting heat, that means after getting energy, we can say. Here again, after getting heat energy, they transforms to gaseous state. Here, as and when this solid substance is getting heated, these particles, if we are not heating, solid particles, all those particles will be nearby. They themselves stand close by. They won't move anywhere if we are not heating them. But once we heat, these particles gain energy. As a result of it, they start to move from one place to another. Then as a result of it, this solid substance changes to liquid substance. So they move little here and there. The molecules difference, that means the intermolecular distance, little far from each other. Again, when we supply heat to it, again these particles move from one place to another. As a result of it, you can find that here the particles are far from each other. So here now, as and when we supply heat to this solid, we are supplying heat to this solid. As a result of it, these particles which were alone standing and shaking, or we can say vibrating, they start to move from their force of attraction little bit. They leave. As a result of it, they start to move from one place to another. Again, when we heat, they start to move little more far from each other. Then the state of each substance, we can say that from solid to liquid, again liquid to gaseous state. That means a change of the state is occurring if we supply heat to it. So here now, to the solid we supplied heat energy. As a result of it, it became liquid. Again we supplied heat energy, it became a gaseous state. We can say that here ice transformed to water, water transformed to steam, as and when we supplied heat. As and when we supplied heat means we supplied energy to ice. Again we supplied energy to water. When we supplied energy to ice, it transformed to water. Again when we supplied energy to the water, it transformed to steam. Now when we cool it, that means if we are cooling steam, that means we are removing energy from it. As a result of it, you can find that here means their energy more. As a result of it, they are far from, these all molecules are far from each other. As in when we remove the energy, that means when we cool it, that particular time we can find that these particles start to move little less. As a result of it, the distance between the molecules of water is little close by. Now again when we remove the heat from it, that means again we cool it. We can find that here again no energy supply. As a result of it, we are removing the means heat energy. As a result of it, particles of water coming very close by. Then we can see the movement here. Here more movement. Here less movement. Here all the particles are coming close by. Then their attractive force is becoming more. Then they stand in one place and they just start to shake. They won't move anywhere. Or shaking, or we can say just they stand and vibrate. Now we will study the characteristics of different states of matter. We had already studied now, that is solid, liquid and gaseous are the different states of matter. In different states, the matter shows different characteristics. Let us see each state shows which type of characteristics. First you see here solid substance, that shows which all characteristics. If it is a solid, we can say stone, ice, like that way. Now hard substances, wood, such all substances are having which property when it is in solid state. One thing, it is a very rigid substance. In case of wood we can say it is very rigid, very hard. At the same time solid is available in the form of plastic. So its character you people are knowing already. Plastic bucket you seen, plastic compass box you seen, plastic different containers you people seen. So their plasticity, that is a characteristic of a solid. Rigidity, hardness, that is a characteristic of solid state or solid substances. Again one more characteristic, that is elasticity. Elasticity means what? Now rubber band is there, rubber materials are there. They are having the stretching ability. Their length we can be able to increase by pulling. So that property also showing by the solid substances. So we can say that if we are having solid substances, which all property it has? One thing, solid substances are very hard, very rigid. Even plastic substances are there, solid. We can say that plastics are coming under solid. They are having a property, that property is known as plasticity. Another one, we can say that rubber is having stretching ability is there. So we can say that that is showing one property, that property is known as elasticity. So elastics are having elasticity property. Now what is about liquid? Liquids having such a speciality, water only we can take. Now rainy season, you can see that water is having the property of flowing. The flowing property of the water or liquid, that is known as fluidity. So water is known as fluid. Why? Because it is a flowing thing. It can move from one place to another in the open place. We can say that now through the road, even through the field, through any such open area will be there. If rain falls, you can find that water flow from one place to another. So we can say that we can count water as a fluid. Another thing, that is gaseous substances, air, oxygen, carbon dioxide. All these gases are having the capacity to move from one place to other, flow from one place to other. So air nowadays means we people are seeing such a heavy wind is blowing. So that is also move from one place to other. So we can say that this wind or air or different types of gases, they all are fluids. They are having the capacity to flow or move from one place to other. Now other property, that is solid. If we are taking a solid substance, this is a solid substance. It is having fixed volume. Its size remains same. Here definite volume. Definite means a fixed volume it has. Now in case of, if we are taking water, if it is taking in a container, then it remains in the same condition. So we can say that now this much water we taken. So here means empty space is there. This much quantities of water is there. So we can say that water has a definite volume. At the same time, if we are taking air, suppose in this class we are taking air. But how much air is there? We cannot see. Even we cannot feel. Plus it cannot remain in one place. It moves from one place to other. So we can say that air has no definite volume. So we can say that air has indefinite volume. Water has definite volume, solid has definite volume, but at the same time gas has no definite volume. Here how much air is remaining, that also we cannot be able to judge. So we can say that air has, or gaseous substances has, no definite volume. Now other thing what is saying, what is the shape? That means the shape of the solid. If this solid substance, if we are counting, we can say that it has a definite shape. At the same time, water if we are taking, that water is getting or forming the shape of the container in which we are pouring it. Here now, in this also water is there, in this also water is there. Here means its a shape is, the container's shape is different. So water is getting the shape of this container. This container, its shape is different. As a result of it, water is occupying or getting shape of this container. So we can say that water has no definite shape. Solid substance, anywhere you put it, this substance anywhere you put it, even then its shape is not changing. So we can say that solid substances are having definite shape. At the same time, liquid or water has no definite shape. Even air has no definite shape. Now, other property, that is compressibility. Compressibility means whether we can be able to contract them or not. If it is a hard substance, that means this substance, only I am counting this thing, this wood. So we can see that even if we are pressing, its shape is not going to compress. Its size is not going to reduce. So we can say that it remains in the same condition. So it has negligible compressibility. We cannot press it. Such a hard substance is this. So we can say that solid substances are having least or no we can say, no or negligible compressibility. We cannot press it. At the same time, liquid substances, if you are filling water inside the balloon, or we can say inside any other plastic things, so even we can say some beds are there, bed made with the help of, or inside the bed, air pillows you see in same way, water filling inside the bed for some sick people. So sick means disease is there, such a old people they are getting disease and all. Sometimes what is there, their body should not get any cut. For that making them to lie on the water beds. So such a water bed, when we are pressing little bit we will feel means we can be able to compress it. So we can say that liquid substances are having little, or here what is here given, here compressibility, very small, very little we can say compressibility, little we can be able to press it. At the same time we can say that here in the case of gaseous substances, suppose air pillow is there, or we can say that balloons are there, in that all air we are filling. When we are pressing means it is pressing. So we can say that they are having very high compressibility. Compressibility means we can be able to press them. Solid will be there very hard, even if we are pressing, no difference will be there. Water is there inside the container. Now inside the balloon also we are filling water. Even then if we are pressing it, little bit it will go inside. So we can say that it has very small compressibility. Air pillows, air, what we can say, air bed or air anything, air filled things. Even we can say football or balls and all. Little bit means if we are pressing air, especially we can say air-filled balloons, air-filled pillows. They all means if you are pressing means we can be able to compress them. We can be able to press them. So we can say that that is known as or we can say that air has more compressibility or very high compressibility. Now another thing what is saying, intermolecular force, that I had explained. If it is in the solid state, particles are very close by, so their attractive force is very high. Liquid substances, their particle distance is little far. As a result of it, attractive force is little less. Gaseous substances, air, their particle distance is very high. As a result of it, attractive force is very, very less. Now same thing only here it is given. This moderate means medium. So here in the case of solid substance, intermolecular force of attraction, their attractive force is very strong. In case of liquid substance, moderate. Moderate means medium. Medium force of attraction they are having. Medium force of attraction. In case of moderate means medium force of attraction in case of liquids. Now in case of gaseous state or gaseous particles, there or gaseous substances we can say. So inside, that means gaseous substances like we can say air, carbon dioxide, oxygen, such substances, their particle distance is very high. As a result of it, they are having very, very weak force of attraction between the particles. Already I had explained, in case of solid, all particles are very close by, so their intermolecular force of attraction is very high. In case of liquids, they are little far from each other. As a result of it, their intermolecular force of attraction is moderate or medium. In case of gases, if we say, their intermolecular distance means in between two molecules, their distance is very high. As a result of it, force of attraction is very, very less, very weak force of attraction. Here same thing is their distance between the particles of solid very close by. They are not having any distance or any separation. We can say that they are clinging each other. They are close, very, very attractive force they are having. They have no movement at all. So we can say that they are clinging each other. They have no difference or no means between the particles there is no gap. No gap here. At the same time here little gap. That is moderate distance between the particles. Here means what is saying, minimum distance between the particles. Between two particles very, very less gap is there here. Here we can say that very less gap. That means between the particles there is minimum distance. Here we can say that moderate or medium distance between the particles. Here we can say that very large distance between the molecules. This is the case of gas. This is the case of, we can say, liquid. This is the case of solid. So these are the different characteristics of matter. That is also matter is available in three different states already you studied: solid, liquid as well as gaseous state. Now solid state has these all characteristics, liquid state has such characteristics, gaseous substance has various characteristics. Now we can say that solid substance is very rigid, very hard, very strong. Liquid substance, example water, you people already studied. Now they are having very much, in case of they are flowing substances. Then gaseous substances also having gaseous substances moving from one place to another. So gaseous as well as liquid substances, we can say that they are fluid substances. Now in case of solid substance, they are having definite shape is there. Compressibility, that is very negligible. Negligible means that no, we can say no compressibility with the solid substances. But in case of liquid as well as gaseous substances are having, in case of liquid substances, they are having very less compressibility is there, pressing ability is there, contracting ability is there. At the same time, in the case of gaseous substances having very high compressing ability, we can be able to press gas-filled substances. So they are having the capacity to compress. If we are supplying pressure to the gas, it will be compressed, it will contract. Afterwards we can say that such a substance can turn into even a liquid. In case of gas cylinder, in that gas only filled, but under pressure gas filled inside. As a result of it, gas is present inside the gas cylinder in the form of liquid. But in case of air pillows, even balloons, in that all air present in gaseous form, we can be able to press it. Now here intermolecular force of attraction you people studied, distance between the particles you people already studied, volume matter. In case of solid as well as liquid has a definite volume. In case of solid, volume means a size. In case of solid substance, its size remains constant. At the same time, in case of water, in which container they are there, that substance, that container's shape they attain. At the same time, volume remains. They won't move like air from one place to another. If we are filling and keeping in a container, that container's shape it will get. If we are openly leaving water or any other liquid, it will flow. Otherwise, if we are filling in the container, even if it is there in the open condition, even if we are opening, it will remain in same condition. So we can say that it has definite volume. At the same time, if we are opening and keeping air, then it will move from the container. Then we cannot be able to understand how much gas is inside. In case of water, we can be able to see it. This much quantity of water only present inside. Even if water open this, it won't move upward. Thank you.